Hello, welcome back students. So today again we are going to start with the chapter inside the atom, which is chapter number 5 of your science textbook. Students, in my previous video we had already discussed about Dalton's atomic model, Thomson-Plum pudding model of atom and Rutherford scattering experiment. So in this video we are going to learn more further. So student, if you had missed previous video, you can check the link into the description box. From there you can click and learn about the first module of this chapter. So student, let's proceed. Students, before beginning with this chapter, let us discuss what are learning objectives of this module. So, you are going to learn about Bohr's stable orbit model in the year 1930 and distribution of electrons. Students, let us start with the Bohr's stable orbit atomic model, which was done in the year 1930. Let us discuss about the scientist Niels Bohr. Student, in the year 1913, Danish scientist Niels Bohr explained the stability. Student, stability means firmly fixed, it is not movable, of an atom by putting forth stable orbit atomic model. The important postulates of Bohr's atomic model are as follow. The first postulate of Bohr's atomic model was that the electrons revolve around the atomic nucleus, lie in the concentric circular orbits at certain distance from the nucleus. Student, as you can see, in between, in the center, there's a nucleus. And in nucleus, there's a proton and neutron. And then electrons is on a specific orbit which keeps on moving. So student, these electrons revolve around the nucleus, which is at a certain distance. As you can see, the distance between atomic, that is nucleus and electron, there's a distance. Yes. So this was the first postulate of Bohr's atomic model. Now, the second postulate says that the energy of an electron, student, energy of an electron is constant. Energy will not change when the electron is in a particular orbit. Students, third and the last postulate says that when an electron jumps from an inner orbit to an outer orbit, जब वो जंप करता है फ्रॉम इनर ऑर्बिट से आउटर ऑर्बिट में, तो वो एब्जॉर्ब करता है एनर्जी. एनर्जी को एब्जॉर्ब करता है, जो कि इक्वल है डिफरेंस ऑफ इट्स एनर्जी लेवल. और जब वो जंप करता है बाहर से अंदर की तरफ, फ्रॉम आउटर ऑर्बिट टू एन इनर ऑर्बिट, इट एमिट्स एनर्जी. वो एनर्जी को छोड़ता है, एमिट करता है. किसके इक्वल टू द डिफरेंस ऑफ इट्स एनर्जी लेवल. अंडरस्टूड. जब इलेक्ट्रॉन्स जंप फ्रॉम एन इनर, अंदर से बाहर की तरफ ऑर्बिट पे जब वो जंप करता है, तो वो एनर्जी को एब्जॉर्ब करता है. और जब वो जंप करता है बाहर से अंदर की तरफ, तो वो एनर्जी को एमिट करता है, मतलब एनर्जी को छोड़ता है, देता है. दिस वॉज द लास्ट पोस्टुलेट. Student, this picture I had put for your reference. As you can see, in the center there's a green and blue color circle. That is nothing but the nucleus. And you can see around that there's a silver color circle which is called orbit. And on that there's a silver color dot. That is nothing but a electrons. So electrons keeps on moving on the orbit around the nucleus. Now when this electrons jumps from one orbit to next orbit, that is from inner orbit to outer orbit, then it will absorb the energy. And when the electrons jumps from outer orbit to the inner orbit, it will emit energy which is equal to the difference in its energy level. Students, some more atomic models were put forth after Bohr's atomic model. Atomic structure was studied at depth with the advent of a new branch of science called quantum mechanics. Students, let us learn about the structure of an atom. An atom is formed from the nucleus and the extranuclear part. These contain three types of subatomic particles. The first subatomic particle is nucleus. Now, the atomic nucleus. First of all, nucleus is positively charged. Almost entire mass of the atom is concentrated in the nucleus. Means the weight, the mass of atom depends upon the nucleus. Okay, it is already embedded, means concentrated into the nucleus. Now the nucleus, inside the nucleus, it contains two types of subatomic particles and they together called nucleons. So what are they? They are protons and neutrons. So now first subatomic particle of nucleons is protons. Student, proton is a positively charged subatomic particle in the atomic nucleus. The positive charge on the nucleus is due to proton in it. So student, once again have a look on this image, which is, as you can see, in the center there's a red color circle. Okay, and there's in between there's a positive symbol. So student, this is nothing but the proton, which is positively charged, and this positive charge is because of the proton in it. Now a proton is represented by the symbol P. Each proton carries a positive charge of +1 E. E means a charge. Once again I will repeat, student, each proton carries a positive charge of +1 E. So 1 E is equals to 1.6 into 10 raised to minus 19 coulomb. When total positive charge on nucleus is expressed in the unit E. Student, once again I will repeat, when total positive charge on nucleus is expressed in the unit E, its magnitude is equal to the number of proton in the nucleus. The number of protons in the nucleus of an atom is the atomic number of that element. Okay, it is atomic number. Okay, the number of proton is the atomic number of that element and is denoted by the symbol Z. Mass of one proton is approximately equal to 1 U or 1 dalton. So next subatomic particle is neutron, and neutron is electrically neutral, means no charge, neither positive nor negative, and it is denoted by the symbol small letter n. The number of neutron in the nucleus is denoted by the symbol n. Atomic nuclei of all the elements except hydrogen with atomic mass 1U contain neutrons. Student, have a look on the image, which is right hand side. Okay, in between, student, you can see red color and blue color dots. Once again, student, I will tell you that this coloration is only for your reference. Okay, so this red color, I had given this red color as a neutron, and that blue color is as a proton. This proton is positively charged and neutron is no charge. Okay, and these together are in the nucleus. The mass of a neutron is approximately 1U, which is almost equal to that of a proton. So student, the mass of neutron and the mass of proton is almost equal. Let us see about extranuclear part. Student, extranuclear part in the atomic structure includes electrons revolving around the nucleus and the empty space in between the nucleus and the electrons. Student, as you can see in the given image, there's a nucleus which consists of a proton and a neutron, and electrons which keeps on revolving around the nucleus, and there's a empty space. As you can see, there's a empty space between nucleus and electron. Okay, so this is extranuclear portion. Okay student, let us talk about now electron. Electron is a negatively charged subatomic particle, and it is denoted by the symbol E. Student, each electron carries 1 unit of negative charge, that is -1 E, nothing but a electron. Student, have a look on the given image. As you can see, in between, in the center, there's a nucleus. Green color, that is proton. Yellow color dot, that is neutron. And you can see yellow color circle which is revolving around the nucleus is nothing but the orbit, and on that specific orbit there's a electron which keeps on revolving around the nucleus. This electron is negative in charge. As I told you student, that electron in the extranuclear part keeps on revolving in the discrete orbits around the nucleus. Now student, this orbit being three-dimensional in nature. Okay, once again I will repeat, this orbit being three-dimensional in nature, so a term shell is used instead of the term orbit. The energy of an electron is determined by the shell in which it is present. Student, as you know that number of electron in the extranuclear part, okay, is equal to the number of proton in the nucleus. Once again I will repeat, the number of electron, okay, the number of electron is equal to the number of proton. Therefore the electrical charges are balanced. Okay, because the number of electron is equal to the number of proton. That is why the electrical charges are balanced and the atom is electrically neutral, means no charge. Student, once again have a look on this image. This is a structure of an atom of a carbon element. What we had studied, student, that in an atom, in between there's a nucleus. Okay, inside the nucleus, there's proton and neutron is concentrated. Proton being positive in charge and neutron is no charge. Then there's a extranuclear part in between the orbit. As you can see, this black color circle, this is nothing but the orbit. On that orbit, there's a green color dot which is negative. That is nothing but the electrons. Electrons are negative in charge. It keeps on revolving around the nucleus on its discrete orbit. Student, this orbit being three-dimensional in nature, that is why the term shell is used instead of a orbit. Now, the number of electron is equal to the number of proton. That is why the atom becomes electrically neutral. Okay, student, now use your brain power and answer the few questions. So, how many types of subatomic particles are found in atom? Think, student, think. Okay, so here is the answer. There are three types of subatomic particles found in atom, that is proton, electron and neutron. Which subatomic particles are electrically charged? Think. Okay, so answer is protons and electrons are electrically charged. Next is, which subatomic particles are present in the nucleus? So, protons and neutrons are present in the nucleus. And the last one, where are electrons revolving around the nucleus placed? So, electrons are revolving around the nucleus is placed in a specific orbits. The mass of an electron is being negligible. Student, negligible means so small that it would not be taken into consideration. Therefore, the mass of an atom is mainly due to the protons and neutrons in its nucleus. The total number of protons and neutrons in an atom is the atomic number of that element. The mass number is denoted by the symbol A. Okay, mass number is denoted by the symbol capital A. The convention to denote atomic symbol, atomic number and mass number together is shown as follow. See, student, how we can write these three together. First of all, atomic symbol, atomic number and mass number. So, symbol A and Z. Student, symbol here will be any of the symbol. Like for an example, I'll take carbon. As you can see carbon, capital C. Then A, capital A is nothing but a mass number. Okay, don't forget, student, once again I am repeating, capital A means a mass number. So 12, this 12 is nothing but a mass number of carbon. and down you can see a capital Z. So capital Z is a atomic number. Okay, so 6 is a atomic number of carbon. Means that atomic number, that is the proton number of carbon, is 6 as I told you, and mass number of carbon is 12. From this it is also learned that the nucleus of carbon contain 12 6, that is 6 electrons. See, mass number is 12. Mass means inside nucleus there will be proton and neutron. Okay, means together it is 12. That means equal number of proton and will be the equal number of neutron. If mass number is 12, that means proton is 6 and neutron is 6. That means electron will be 6. Let us see next topic, that is distribution of electrons. As per Bohr's atomic model, electrons revolve in stable shells. These shells have a definite energy. The shell nearest to the nucleus is called the first shell. The next shell is called the second shell. A symbol N is used for the ordinal number of shell. So student, as we discussed that the shell which is nearest to the nucleus is called first shell, then the second shell, third shell, and goes on. Now these shells are referred by the symbols as well, and these symbols are capital K. The first shell will be named as a K, second shell will be named as a L shell, then M shell, N shell, and goes on. Corresponding to the ordinal number, that is N is equals to 1, 2, 3, means corresponding to the number of a shell. The maximum number of electron a shell can contain is obtained by the formula 2 into n raised to 2, that is n square. As the magnitude of n increases, the energy of an electron in that shell increases. Student, now on page number 32 of your textbook, one table is given. So you are going to complete that table. Student, we had learned about the formula 2 into n raised to 2, that is n square. By doing this formula, we can find out the number of electrons that orbit will be having. Okay, as you can see the symbol K. N means number of orbit is 1. First shell is that, so we will put the values in the formula. So 2 into 1 raised to 2. So 2 into 1 is 2. So the number of electron in K shell will be 2, not more than that. Okay, now let us see about the L shell. N will be 2 because this is the second cell. That is why we are going to write it as a 2. Now in formula I am going to put the values. 2 into n. What is the n of L? Is 2. Okay, so 2 into 2 raised to 2. So 2 2s are 4. So 2 into 4 is 8. So number of electron in L shell is 8. Not more than that. Okay, only the 8 electrons will be there in the shell L. Now M. This is the third shell. So N is 3. So 2 into 3 ka square. 3 3s are 9. 2 9s are 18. So number of electrons in M shell will be 18. So now student, you can do this table into your notebook. Students, now I want you to do a small assignment based on this module. This is the Use Your Brain Power on page number 32 of your textbook. The first question, the symbol used for oxygen is O. There are 8 protons and 8 neutrons in its nucleus. From this, determine the atomic number and mass number of oxygen and arrange this in a conventional symbol. Student, we already learned about this, Second question, atomic number of carbon is 6. How many electrons are there in a carbon atom? Next question, a sodium atom contains 11 electrons. What is the atomic number of sodium? Next question, the atomic number and mass number of magnesium are 12 and 24 respectively. How will you show this by the convention symbol? And the last one, the atomic number and mass number of calcium are 20 and 40 respectively. Deduce the number of neutrons present in the calcium nucleus. My dear students, here we completed with this module. So in next module, we are going to learn about electronic configuration of elements, valency and electronic configuration, valence electrons. So student, if you like my video and you want me to do such an educational video, so please do like, share and subscribe my YouTube channel. Till then student, take care. Thank you.